Hey everyone, it's Nick. Welcome back to another duality repair video. Tonight I have something a little different to look at and repair. This is a Hewlett Packard 35900B model dual channel interface. And what this is it's the interface between a piece of analytical testing equipment and its associated PC and software. And so most commonly the type of piece of equipment used with this is a gas chromatograph, for instance. And not that it's critical to this repair, but it is very interesting. A gas chromatograph is a piece of equipment that is used to separate out constituent components within a sample. Most commonly, or most familiarly, it is used to identify the amount of alcohol in your blood. So if you're pulled over and you're suspected of drunk driving and they draw your blood, they're going to use a gas chromatograph to analyze and determine the amount of your blood alcohol content. So pretty interesting. It's used in many other applications in different industries, but that's just one. That's probably the most familiar application that a gas chromatograph is used for. So this is a dual channel interface. It's pretty simple front controls here, really just start and stop, and then channel A is for one piece of equipment and channel B is for another piece of equipment. You can use dual mode. You can use use it for two pieces of equipment at once, or just one mode, one channel at a time. And basically all this does is it converts the analog signal to a digital signal. You see the analog and digital here. So the analog signal from the piece of equipment converts it to a digital signal and sends it to the computer so that they can communicate. And that's pretty much it. It's pretty simple. But I bought it because I was pretty curious. This actually belonged to the company that I worked for previously. And they're local here in the Twin Cities here in Minnesota. And they were selling this on eBay for parts. And it had the very familiar symptom of not being able to power on. And since this is a little bit of my history, I never worked on this unit, but I worked with something similar to this at that company. I thought it was interesting. I thought it'd be interesting if I could repair it, make a video on it. So let's dive right in. Let's make sure that the symptom that they're reporting is accurate. So I have it plugged in, and let's power it on. I should get a green LED power light here, and then I believe I should get some sort of LED illumination under the status. So let's power it on. And nothing. I'm not sure if there's a fan or anything in this unit, but I don't hear any fan. I didn't hear any relays, nothing. Try one more time. Nothing. And there's no other power button or anything associated with it on the front or the back. So before we open it, let's just check the fuse. And you can see how simple the back is while we're back here. So it's seen better days cosmetically. Looks like it's been pushed in a little bit here. Probably been pushed against the back of something in the laboratory. But you have the two COM ports for each instrument, and then you have the two COM ports to the PC to control each instrument. So pretty simple. Now let's pull that fuse out and see if that's blown. And obviously if that is, I'm not just going to replace it and power it on because it blew for a reason, right? So let's just see. It's a 3-amp fuse. What's your guess? I don't know. I'm going to say it's blown. No! See that? That's a thick fuse. It's hard for you to see. That's intact. I'll check it with a meter later, but I'm gonna open it anyway. It looks to be intact. So that's nothing, no major shorts inside. Okay, so let's open it up. Looks like there's just a few screws on the back here, maybe one or two on the bottom. Nope, just two on the back, and we'll get it open. Alright, so here it is with the cover off. Obviously we have this main control board here right on top, so I'll have to take this out to get to the power supply to be able to repair this. But let's take a quick look around at this first. Not too much to look at. We have our DC to DC converter over here. This ribbon cable looks like it's the control to the front interface, so all the buttons on there and the LEDs on the front. And our main processor looks like it's going to be right here. And we have this protective cover over here, I'm guessing for some sort of high voltage, just for service protection there. And the only really curious thing that I saw is this. So there's a 7-segment display here, and that's definitely not visible with the cover on, so that must be for some sort of diagnostic or troubleshooting, calibration, something. So I thought that was pretty interesting. I'd be curious to see what that does if we get this working and we can power it on, if that's actually doing something, if it's counting something. That'd be interesting. But not too much to look at here. The board looks pretty good, in pretty good shape. A little bit dusty, but that's to be expected. And so I'm going to remove this so we can get down to the affected unit, which is the power supply. Hopefully it's directly under this. Who knows? Maybe there's another board or something underneath this. I don't know. And so it looks like it won't be too difficult to get off. Maybe 1, 2, 3, 6 screws, and removing some of the connectors. So I'll get this off and we'll see what's underneath. I was able to get that top board out pretty easily, and I'm getting closer. Took me a while to figure out how these boards were mounted. So again, here's our power supply right here, and I was a little worried because you can see the casing that's here. It's actually welded, or called riveted to the chassis or the frame. So I was like, well, shoot, I can't even get this power supply out. But it's slotted, so it should come out just like this board does. I had to unscrew it from the back, but then it's just rides in these guide rails here on either side, and it slides out. And so obviously I'm almost there. I'm at the power supply section. But I'm having a fun time trying to figure out how to get this thing out. It's not coming out like that one is. So I don't know. I don't see any other screws. The only other 2 screws, whoops, are to hold on the fan here. These 2 for the fan. I remove this screw, this ground screw, and I don't see any other screws, so I'm going to have to poke around a little bit more. I don't want to pull this too hard for fear that it's attached somewhere else and I'm going to break it. So I'll be back when I figure out how to slide this out, but we should, once I get it out, we'll have access to directly to this power supply board. Alright, I managed to get the board out of the unit. I was missing 1 screw here on the side, and then it just slid out very easily like the other board. And so here it is. This is a switching power supply. I did a brief initial inspection. I looked at the capacitors. None of the capacitors, surprisingly, are bulged. I don't see any signs of leaking. I also don't see any other signs of burning, so any sort of burn marks or anything like that. So surprisingly, nothing obvious on the supply right off the bat. Now, I don't have any schematics, so I find it helpful when I don't have any sort of schematics or diagrams when I'm working with a unit, even something as seemingly simple as a switching power supply, to draw a block diagram. So that helps me kind of compartmentalize certain parts of a board, and it also gives me certain points of a board to check for voltages or signals or whatever. And so let's just go through this really quickly, and this is common to pretty much all switching power supplies, and this is no exception. So let's start with AC in. AC in's coming in here through the plug, right? And it goes first through the fuse, which is this fuse holder right here, and we check that. That seems to be good. I'll check it with a meter to verify, but physically it looked to be in good shape. It's then going to go through some initial filtering, and so that's going to be capacitors here, this giant inductor here, and some more capacitors right here before it goes to the bridge rectifier. And the bridge rectifier is here. Bridge rectifier is going to rectify the voltage into DC, pulse DC. And then again, this is very generic, so obviously there's a lot more going on than just this block diagram, but this is just what I have drawn up. So from the bridge rectifier, it's going to go through the drive transistor, which is here. In this case, there's only 1. Sometimes you have 2 transistors driving in a push-pull configuration. This looks to be a single transistor configuration. So your voltage is going to be driven through this transistor by a drive IC. So there's a drive IC that's going to turn the transistor on and off, or it's going to alternate the polarity, so that your polarity of your voltage is going to swing up and down to create AC through the transistor. And through the transistor, we're going to go to the transformer, which is here, which of course is going to transform the voltage. And we're going to move on to this side where we get to rectification. So looks like we have 2 diodes right here for rectification. And there may be more that I'm missing, but those 2 definitely, you can see the giant heatsink here. So we'll rectify it so that we have DC voltage here, and then some more filtering, so that's what all these filter capacitors are, and I think I saw a few inductors and inductor there. So some more final filtering before we get to DC out at the connector. So it kind of flows pretty well with this block diagram from left to right on the board as well. And so as I said, this gives us having this block diagram gives us familiar points to test. We don't have a schematic that tells us what voltages should be where, and we don't even have, although each component is labeled on the board, I don't see any test points that are labeled with what voltage should be where. And even on this connector here, it's got, I don't know, maybe 15 pins, and although the connector is labeled, the connector itself is labeled, there's no label of what voltages should be where. You know, they might only use 2 or 3 pins on here for voltage. I don't know. They might use all of them. There might be 5 different voltages. There might be 2. I'm not sure. So we can at least walk through this diagram and walk through the supply and check familiar points for voltage. So the first thing I'll do is check the fuse of the meter and make sure it's not open. And I think the best, the best place to check next is the bridge rectifier. So we'll be able to see if we have AC voltage going in and DC coming out. That's a great place to start. If we have that, we can rule out this part of the circuit and we can move forward here. So let's start with the fuse and the bridge rectifier. Obviously, I'll leave it off while I'm checking the fuse. Just make sure it's got continuity there. Sure it will. As I said, it was a beefy, this is a 3 amp fuse, and so if that thing blows, it's going to be pretty obvious. Fuse is going to be here. Yep, okay. So the fuse is okay. I'm going to leave it upside down as I plug it in. I just need to make sure I know where here's that bridge rectifier right here. So you see these 4 pins here, 1, 2, 3, 4. 2 outer are always going to be AC and the 2 inner are going to be DC. So we'll check for AC and DC on those 2 pins, or those 4 pins I should say. And then we'll see where we're at. So let me plug it in. Make sure it's not powered on. Double check there. Alright, obviously if you're going to plug in something like this and you have exposed parts of the circuit, be very, very careful. There's no really fun way to do this. Unfortunately, I couldn't test this when it was in the unit. I can't test any of these components because it was all hidden in that compartment, which you know, was riveted to the unit. So not much I can do there. Just going to be very careful. Hold the edge of the board as I plug it in. Even though I don't have the power on, there's still going to be well, no. I'm not plugged into the socket either. So here we go. Plug it in there. Okay, let's be very careful when I power it on. Alright. No smoke. I mean, we've already turned it on several times, and I'm sure the previous owner has already tried to turn it on and off many times. So, alright, I'm on AC mode. I suppose you should see the meter. And so we check the fuse. I suppose we can check the fuse too. Check for voltage at the fuse. Still can't see the meter. So I'll find a nice ground point, and we'll check here for 120 volts AC, and we have it. So let's just jump straight to the rectifier. That's a good place to go. And again, the 2 outer pins should have 120 volts AC on it. That is very surprising. So as you can see, I don't have any voltage on the outer pins. And let me make sure I'm making good contact. I am. Those should definitely be, yeah, AC. And then so obviously we're not going to get any DC out of the center 2 pins. There's no AC present on the outer 2 pins. That is very surprising. So, interesting. I was definitely suspecting that the front part of the circuit would be okay. It usually is. It's usually in this control part of the circuit and the drive part of the circuit. So, I guess we're going to work backwards here. Let me turn it off, unplug it, turn it back over, and take a closer look at that front portion of the circuit here. As I said, really. And as you can see on the block diagram here, and of course, in this case it's probably not true since we're not getting voltage there, but in most cases you want to be very careful, even after powering it off of large filtering capacitors, because they could potentially store a lot of charge. Even though we're not getting voltage to this rectifier, which would prevent it from having voltage going past it, I'm always assume that there's voltage on all these capacitors. So just be cautious. So let's take a closer look here. And there's not that many components in this front end here. Obviously, I'll probably have to go back and forth for to check what makes contact with what. So we have, let's see, really we just have a couple of capacitors, maybe 8 capacitors, and this giant inductor here, and that's about it before we get to this rectifier. So something inside here is probably open. I doubt it's shorted because we would probably blow the fuse. So something might be open, and I'll have to check for that. I don't see any MOV here, any MOVs. There might be. It's a capacitor. It's hard to tell. I'll have to take a closer look, probably off camera, and I'll let you know what I find out and what we're going to test next. But very surprising that it's in this part of the circuit, at least. For now, I'm assuming this part is good. But this part is definitely, there's something wrong here. So let me take a closer look offline, and I'll come back and let you know what I found. All right, I'm fairly confident I found the issue, or at least one issue. I inspected this front section of the board here, and I looked on the top for any evidence of shorts or anything leaking. So there's no electrolytics on here, so no concern there. So I inspected the back for any issues with the traces or any leaking coming onto the back of the board, and I did find something, so I'll zoom in here. I'm pretty sure this is going to be our issue, or at least one of the issues. So what I'm looking at is this right here. So hopefully that comes through okay. There you go, you can see a little better there. See that crack there? So this trace has lifted fairly significantly. Alright, and what this is this is one of the legs of the inductor. This giant inductor here. So I'm not surprised. This is heavy. This is probably the heaviest thing on the board, and there's probably also a lot of heat, heating and cooling here, going on over many years, decades really, and so it finally caused it to give. And so, of course, the only way to tell for sure is to check for continuity, and you can kind of see it there, a little bit of discoloration. That's the trace being lifted. And so let's check for continuity. Obviously, you can see the trace itself should go from here to here and then to here. And you can see we don't have any continuity. And so this is directly off of our, this is actually the switch right here. So we have power coming up to the switch here on either side, and this is the power switch. And so right now the switch is off, right? Not getting any continuity. Turn the switch on, and then we have power jumping across the switch as it should, and then it should flow through the through to this point of the inductor and then through the inductor. Well, we're not even getting to the inductor, so that is definitely why we're not getting, at least getting voltage to the rectifier. Now, is that our only issue? I have no idea, but it's definitely an issue, and so I'll have to fix that. I'm not sure if I can repair the trace itself. I think the best thing to do is to just make a jumper wire from here to here, a nice beefy wire, and maybe cut the trace so that it's independent and it's not seeing partial connection there. So I think I'll do that now. I'll make a jumper wire here, and we'll verify we have continuity. And we'll turn it back on, and we'll make sure we have voltage to this rectifier here, and we might as well check for some voltage at the outputs here. Again, I don't know what they're supposed to be here at the output, so pretty accessible pins right here. But we should be getting something. There's no way we're getting voltage there right now. we're not even getting voltage to the rectifier, bridge rectifier. So I'll make a jumper, I'll power it up, and we'll see if we have any outputs here. If we do, I'm going to clean up this board, we'll get everything back installed, and we'll see if it powers up. Alright, so as you can see, I repaired the trace there. I bypassed it with a new wire, and so now we have continuity through the switch to the inductor. And so let's power it up and check for voltage here at that bridge rectifier as we did before. So it's plugged in, it's powered on. Let's check for AC voltage. I believe before I mentioned that the AC was on the outer 2 pins, but I was incorrect. It's on the inner 2 pins. So let's check AC on the inner 2 pins here. We should have 120. And let's see. 120, there we go. Now let's check the output. DC, depending on what type of output this is. Okay, so you can see the 1 there. So this has got a voltage doubler in there. So it's normally straight out of a bridge rectifier, it'll be 1.4 times the input due to the RMS value. So it should be like 160 to 170 volts DC. This looks like it's a doubler, so this is going to be, 300 and some DC out. Yeah, there you go. 332 volts DC out. Okay, so let's check for some outputs. I could do it here at these pins on the back, but I don't want to short anything. It'll be a lot easier to check the pins on the front, so let's flip it over. Unplug it. Make sure you don't have anything conductive on the bottom if you're going to have your board on the bottom, or if you're going to have your board, the bottom of the board touching the your bench. And so make sure you don't have any loose conductive material, strands of wire, nothing like that. Okay, there we go. And I think I get to use these for the first time. Hopefully they fit. They might be too small for these size pins. I have these nice jumpers from a banana to the female receptacle here. Let's see if it works for this pin size. No, these pins are too big, darn it. Nope, I haven't got to use these yet. So I'll just use standard jumpers. It's okay. Alright, now I'm probing with one probe here, and I'm in the DC mode. Let's get the glare out of there. I'm in the 20 volt scale. I don't know what kind of output we're going to get, so let's just check here. Try and not be in the way. I'm going to start from the pin furthest away from us and move my way forward here. Very promising. First pin, 12 volts. So 12 volts on the first pin. Second pin, nothing. Third pin, 12 volts. Fourth pin, nothing. Fifth pin, 5 volts, 5.1 volts. Sixth pin, nothing. 7, 5 again. 8, nothing. 9, 5 again. 10, nothing. 11, nothing. 12, 4.7, that's interesting. Hope that's not an issue. And our third to last pin is 12 volts on the dot. Second to last pin is 0. And our last pin is negative 12. So we have a bunch of positive 12 and positive 5, and then a negative 12 as well. I feel really good about this. I think we got the power supply resolved. I think we got it fixed. So I'm going to put everything back together. I'll clean up the board a little bit. I'll put everything back together and power it on, and we'll see if we fixed it. Okay, I got it all back together, minus the top cover, just because I wanted to see if it does work, what that 7-segment display does, if anything. So, time to see if our efforts paid off. It's plugged in, let's power it on. Hopefully we hear a fan and we see some lights going. Ah. There we go. So I hear the fan. Obviously we have the power light illuminated. We do have a fault. And then, so let's go to that 7-segment display. That's probably what it's there for, is to give me a fault code, which it is displaying a number right now. There you go. see it's got a number 3. And there was actually another 7-segment display here in the front. Yeah. So, I do have the operator's manual. I'm curious to see what kind of fault that might be. Because I do want to fix this completely if I can. We obviously got the power issue resolved. It powers on, no problem. And here the fan spinning. Yep, it's got good airflow back there. So let me take a look at the manual, see if it's got anything about error codes in there. Hopefully it does. See if we can figure out what's wrong with it. I think I have everything plugged up correctly and there's nothing else to hook up. So this fault light, you know, maybe it's because there's nothing hooked up to it in the back. I don't know. So I'll be back after I take a look at that manual. Okay, so I think as I said earlier, the service manual is very lacking. Not only doesn't have schematics, but it also doesn't provide any information for the error codes. What it does say though is that at startup you do have to have your communication cables hooked up to your PC, and if you don't, you're going to have that fault light remaining. So I think that's what our issue is. It doesn't say anything about specific fault codes, so I can't know for sure, but I believe that's the issue. I have no reason to believe that this unit wasn't working before, and it simply just stopped working because that inductor trace eventually wore and broke free, and so power failed to the unit. And so I'm going to deem this unit repaired and call that a success. Even though we do have that fault light remaining, again, I believe it's due to us not having communication cables hooked up. This is, after all, an interface unit, and so it is checking for communication to the host PC, which we have none. So I have no way of testing this further, but I'm going to call this repaired. Okay, I didn't think I'd be back, but what I was seeing earlier was not normal. It should not fail regardless of if you have connectors plugged in. I found that when I was putting this top cover on that I had 2 extra screws, so I pulled it apart, pulled this front faceplate off, and there was a connector right here that connects the top board to the bottom board, and there are 2 screws holding that in place. So basically I didn't have that seated all the way, and so now I attach those 2 screws. When I power it up, you can see, watch the 7-segment display. It gets to 1, gets to 2. Before it would beep when it gets to 3, and now it gets to 3 and 4 just fine, and it continues on. So this is the self-test, and you can see it hits P for pass, and then now we just get these blinking lights here, and the fault light goes away, and the blinking lights just indicate that we don't have any communication, obviously because I don't have anything hooked up. So now it is absolutely fixed. I feel 100% confident that this thing will work. I'm glad well, I guess I would have figured it out eventually since the screws weren't, had extra screws, but I'm glad I was able to get it 100% resolved. So again, thanks for watching. We'll see you next time.